Hello and welcome back to the course
Fundamental of Electronics and Electrical Engineering.
In this video lecture, I am going to continue with the unit 1, that is DC circuit. In the previous video lecture, I have discussed series and parallel connection of resistor and Ohm's law. Now, in this video lecture, I am going to discuss the topic voltage division and current division rule, which are based on series and parallel connection of resistor, then different kind of energy sources. So let us start with the voltage division rule. So here you can see two resistors R1 and R2 are connected in series across the voltage V. Now voltage division rule is used when resistors are connected in series, and it is used to determine the voltage across the resistor. As battery of potential V is connected, the current I will start to flow, and there is a common path for the flow of current because both resistors are connected in series, and according to the Ohm's law, the V1 and V2 will be there, which is nothing but the potential difference across R1 and R2. As the same current is flowing, so we can write I1 is equal to I2 is equal to I. Now total voltage V is equal to V1 plus V2. So we can write V is equal to IR1 plus I1R1 plus I2R2. Taking I common, we can write V is equal to I in bracket R1 plus R2. So current of the circuit, total current of the circuit is V divided by R1 plus R2. Now according to the Ohm's law, voltage across R1 is denoted by VR1 is equal to I into R1. Putting the value of I from this equation, we can write VR1 is equal to V divided by R1 plus R2 into R1. Similarly, voltage drop across R2 is also determined using Ohm's law, that is VR2 is equal to IR2, and putting the value of I from this equation, we can write VR2 is equal to V divided by R1 plus R2 into R2. So how to remember this equation? What is the trick? So we can see here voltage drop across R1 is given by total voltage V into the value of the resistance itself divided by sum of the all resistance connected in series. Similarly, voltage across R2 is given by VR2 is equal to total voltage V into that value of resistance, that is R2 divided by sum of total resistance. If three resistors are connected, then in denominator we will be having R1 plus R2 plus R3. Now let us take one example based on voltage division rule. So here you can see two resistors 50 ohm 30 ohm are connected in series across 40 volt battery, and because of that some current will start to flow. So in this example you have been asked to determine the voltage across each resistors and total current. So total current I is given by V divided by R1 plus R2. Battery is 40 volt divided by 50 plus 30. So total current of the circuit is 0.5 ampere. Now using voltage division rule, we can directly find out the voltage across 50 ohm, that is V1 is equal to total voltage 40 into 50 divided by 50 plus 30. So 40 into 50 divided by 80. So that is nothing but the 25 volt. Similarly, voltage across R2 can be find out total voltage into the value of that resistor itself divided by total resistance. So 40 into 30 divided by 80. So 40 into 30 divided by 80, that is nothing but the 15 volt. So this is how you can find out the voltage across the resistance when resistance are connected in series. Now next one is a current division rule. So current division rule is basically used to find out the branch current when the resistors are connected in parallel. So here you can see two resistors R1 and R2 are connected in parallel across the voltage potential V, and because of this current I will start to flow, and I gets divided into the two currents, that is I1 and I2. I1 is a current flowing through R1, I2 is a current flowing through R2. Now we have to determine I1 and I2 using current division rule. Because why it is known as a current division rule? Because currents get divided into the branches, and in the previous case it was known as a voltage division rule because voltage gets divided, total voltage get divided in the voltage division rule when the resistors are connected in series. Here current get divided, that's why it is known as a current division rule. Now here R1 and R2 are parallel, so total equivalent resistance can be given by R equivalent is equal to R1 into R2 divided by R1 plus R2. So total voltage V is equal to I into R equivalent. So we can write V is equal to I into R1 R2 divided by R1 plus R2. Now current through R1 is given by I1, is denoted by I1, and I1 is nothing but the V divided by R1. And value of V we have already found using this equation. So we can write I1 is equal to I into R1 R2 divided by R1 plus R2 into R1. R1 gets cancelled out, so we are having current I1 is equal to I into R2 divided by R1 plus R2. Similarly, current through R2 is given by I2. So I2 is nothing but the V divided by R2 according to the Ohm's law, and the value of V is, we have already value of V, so putting this value of V over here, so we can write I2 is equal to I into R1 R2 divided by R1 plus R2 into R2. R2 gets cancelled out, so I2 is given by I into R1 divided by R1 plus R2. Now, what is trick to remember here? When two resistors are connected in parallel and value of the value of the current in each resistance can be found by very simple technique, that is I1 is nothing but I1 is equal to total current I into opposite resistance R2 divided by sum of resistance R1 and R2. Similarly, current through R2 is denoted by I2, so I2 is nothing but the I2 is equal to total current I into opposite resistance R1 divided by sum of resistance, that is R1 plus R2. So this is a trick to remember, trick to find out the branch current using current division rule. Now one example based on current division rule. So here two resistors 60 ohm and 30 ohm are connected in parallel, and this parallel combination is connected across the 40 volt battery. So current I will start to flow and I get divided into the two parts, I1 and I2. Now we have to find out I1 and I2 using current division rule. So we know to find out I1 and I2 we need to have the value of I. So first finding out the value of I. So V is equal to I into R equivalent. Because R1 and R2 are in parallel, so we can write V is equal to I into R1 R2 divided by R1 plus R2. So putting the value of voltage, current and resistance, so we can write 40 is equal to I into 60 into 30 divided by 60 plus 30. So current I is equal to 2 ampere. Now directly we can find out the value of current through R1 using current division rule. So I1 is total current I into 30 divided by 30 plus 60. So we can write 2 into 30 divided by 90. So total current is 0.66. So current through R1 is 0.66 ampere. Now similarly we can find out the current through R2, that is given by I2 is equal to total current I into opposite resistance, that is R1 divided by R1 plus R2. Now putting the value of I, R1 and R2, we can write 2 into 60 divided by 90, that is 1.33 ampere. So current through 60 ohm is 0.66 ampere, current through 30 ohm is 1.33 ampere. Now we can verify our answer by adding both this value. So 1.33 into plus 1.66 ampere, so it is equivalent to 2 ampere. So I is equal to I1 plus I2. So the value which we have got is correct one. Now energy sources, that is voltage and current sources. There are two types of energy sources, voltage source and current source. Now what is the difference between voltage source and current source? So voltage source is basically used to describe a source of energy which establishes a potential difference across its terminal. Most of the sources that we are encountering in our day-to-day life are the voltage source, like battery, DC generator. These are the different examples. Now current source. So basically current source is used to describe the source of energy that provides a constant current. Ideally you should provide the constant current, and the example of current source is a collector circuit in transistor. So a collector circuit in transistor is used as a current source which provides the constant current. Voltage provides the constant voltage. These are the ideal voltage sources and current sources. But practical voltage source and current source does not provide the constant value. Its value decreases, and that depends on the load resistance. So voltage source provides voltage across its terminal, current source is used to provide the current. Now voltage source and current source are active elements. There are two types of element, active elements and passive element. So voltage source and current source, why it is known as active elements? Because they provide electric energy to the circuit, and the passive elements absorbs the energy. Resistor, capacitor, inductors are the passive element. Batteries, that is nothing but this energy sources, are active element which provides the energy source, electric energy. Now these are the symbols of voltage sources and current sources. So this is a symbol of DC voltage source which is denoted by capital V and plus minus sign inside the circle. If it is a AC source, then it will be denoted by V in bracket T. It is a function of time, and the symbol is, it looks like a sinusoidal waveform symbol. Then current is denoted by a arrow sign, and if it is a AC current, then it is denoted by I of T, and sign of the current remains same in both cases, whether it is AC and DC. But label is different. DC is denoted by capital I and AC is denoted by I in bracket T, which is function of time. So these are the different symbols of energy sources, that is voltage and current sources. Now, voltage and current sources are of different type. It is a dependent sources and independent sources. In the previous slide, we have seen the example of independent sources. Now, as the name suggests, independent sources are the energy sources which does not depend on other energy sources in the same circuit. And another type of energy source is a dependent source. And dependent sources, again, there are two types of dependent source, dependent voltage source and dependent current source. So dependent source provides a voltage or current between its output terminal, but it depends on another variable such as voltage or current in the same circuit. Now, dependent source is denoted by diamond shaped symbol. Independent source is denoted by round symbol, and dependent sources are denoted by diamond shaped symbol. And there are four possible dependent sources. So let us take one by one. Voltage dependent voltage source. Voltage dependent voltage source means what? It is a voltage source which depends on other voltage. Then current dependent voltage source is there. Then voltage dependent current source is there, and current dependent current source is there. So let us see each and every one. So first one is a voltage dependent voltage source. As the name suggests, a dependent voltage source is a one which depends on any other voltage in the same circuit. The definition lies in name. It is a voltage source, but it depends on other voltage source in the same circuit. And voltage dependent sources are denoted by diamond shaped side, you can see here. Now, this is a dependent voltage source because it is a voltage source because it is denoted by diamond shape with plus and minus sign. Now, the value of this dependent source is 60 V1, and V1 is nothing but the input voltage. So this voltage source depends on other voltage. That's why it is a voltage dependent voltage source. Now suppose value of V1 is 2 volt, so value of this dependent source becomes 120 volt. The next one is current dependent voltage source. So as the name suggests, current dependent voltage source is a one which depends on the current flowing in the same circuit. Here you can see this is a symbol of current dependent voltage source. It is a voltage source because it is denoted by plus minus sign, and it is denoted by diamond shaped symbol. Now, the value of this voltage source is Ki1, where I1 is a current flowing through this resistor. So this is the current dependent voltage source. The next one is a voltage dependent current source. So as the name says, this is a current source which depends on other voltage in the same circuit. So here, now it is a dependent source, so that's why it is denoted by diamond shape symbol. Now arrow is there inside diamond shape, that means it is a dependent current source. Now the value of this dependent current source is 0.2 V1, where V1 is a voltage across this resistor. So this is a current source, but it depends on other voltage source. So that's why it is a voltage dependent current source. And the final one is a current dependent current source. So as the name suggests, current dependent current source is an energy source which depends on other current flowing in the same circuit. So here again we are having a diamond shaped symbol with arrow inside, so it is a dependent current source. Now value of this is beta I1, where beta is a constant. In the previous slide you have seen the K, where K is also constant. So, and what is I1? So I1 is a current flowing in this resistor. So this is a current source, dependent current source, and it depends on current I1 which is flowing through other resistor in the same circuit. That's why it is a current dependent current source. So this is all about today's lecture. In this video lecture, I have discussed voltage division rule, current division rule. Hope you enjoy the video. See you soon in the next video of DC circuit. Thank you for watching.